So I'm Mike. I work for a company called Levanto Financial, and I'm going to talk to you about Phoenix today. So this is my first time in India, so I did a little research before coming here. I've worked with a lot of Indian developers before, and one thing that I had to get used to was all of the different head nods. So I know yes and I know no. I'm not sure what this one is, but if someone wants to explain after, just come find me. So I love Ruby. Ruby is the framework that really got me excited about building for the web, right? Before I used Ruby, I wrote a bunch of C++ and Java, and I felt like I was having to do the same stuff over and over again, and I was constantly, trying to work with my team to put structure in place because we had we had our own set of random opinions to go by. So I wanted to start with this because I'm going to pick on Ruby and Rails a little bit today. And just to be clear, this is the alternate talk title. What I'm going to be talking about, I may say it's better than Rails. I may say it's faster than Rails. But another important thing is it would not be possible without Rails. So we're always building on the shoulders of what we had yesterday, to get to tomorrow. So let's talk about opinions. I'm not a computer scientist by education. I'm a physicist and a mechanical engineer. So I really appreciated Ernie's talk this morning. But I'm a product guy who codes. So rather than getting a lot of satisfaction from making an algorithm 10% faster, I like to get a product out faster. I like to build a team that is, it's a team of 5 that scares a company of 1,000 people because we're so productive and we can put something out in 2 days and they take a month to respond. So I started using Rails in the 2.0 release sometime around there, and a lot of my time at Yahoo was trying to get people aligned with conventions. And I couldn't sell Rails there, but I did work with them to get them using Ember.js, which is as close as you can get on the client side to a Rails-like thing. So today we're going to talk about Phoenix, and I'm going to break it down into a couple parts here. First, I think context is important. I think anytime you're talking about something that's coming next, you want to understand why are we keeping the things we're keeping, and why are we throwing the things out that we're throwing the things out? How did we arrive at these decisions? What were the pressures that forced us into this direction? Then I'm going to talk about how you guys have a head start more so than people that are spending a lot of time in other ecosystems. Rails developers can jump into this stuff really quickly and really easily. And then I'm going to contradict everything that I just said there, and we'll talk about some important differences, some important conceptual leaps that you must make in order to be successful working with a functional programming language, working with distributed systems, or treating your web app, which already is a distributed system, like it is a distributed system, more specifically. And then finally, because I believe in pragmatic talks, I like to leave people with something they can walk away with. I am going to help you guys see how you can start using Phoenix today in combination with the Rails app that you may already be working on. So how can you start to experiment with it or use it a little bit or start migrating over to it, but how can these things exist side by side? So where does our story start? We'll begin with this guy, Chris McCord. He, now we know he's the inventor of Phoenix, but he was known in the Rails community for this gem mostly. It's called render sync. And the point of render sync was to have partials that would automatically update on the client side, triggered by server-side changes to data. And this predates recent advancements like Action Cable. So he had to build his own, mechanism for dealing with WebSockets in Rails. It works. It absolutely works. The code is complex, and there are many hoops you have to jump through in order to make real-time work with a Rails app. And so he got it done. He felt like he was putting the wrong pieces together. And just because it works doesn't mean we should be satisfied with it, right? So enter Jose Valim. He was a Rails core team member. I believe he's an alumni now. So he, in 2010, was working on some performance improvements to Rails. And those improvements had to do with Moore's Law. And Moore's Law just says computing power supposedly doubles about every 2 years. And this is, it is a theory that has been proven true, or that matched the reality we observed, I should say, from about 1965 until 2005, at which point we ran into a bottleneck, right? And the way we were increasing computing power mostly had to do with advancements in manufacturing. So we were able to put more transistors into a die and pack as many as possible into a core. But now there's a certain point where you hit other problems, like this thing is small and we can manufacture it, but it's generating so much heat that you need liquid cooling to make this thing work, or to raise it to the performance level it's potentially capable of. So that's why now we see multi-core machines being the norm, right? You probably have one that you write your own code on. The problem is Ruby does not play multi-core well. Ruby was built really to write on a single thread in a single process, and we can use things like sidekick or rescue to kind of hack some asynchrony in there, but predominantly, it doesn't play well with doing more than one thing at once. So he's digging through this stuff, and he basically comes to the conclusion, Jose comes to the conclusion that Ruby and Rails do not give him the tools that he needs in order to make a highly concurrent machine, a highly concurrent foundation for apps that will really take advantage of all of the resources that they're given, right? That will run on your multi-core machine, maximizing the potential. So he starts exploring for other things out there that do this well, and comes to find the Erlang virtual machine. And for those that don't know anything about Erlang, it's a programming language that's been around since the 1980s. It was created by Ericsson. That's what the ER in Erlang stands for. And about half of the telecom industry is built on this. So it's running in cell phone towers and switches and call centers, and it is the reason your text messages reach their destination and your calls can stay connected even if you're on a car driving across town, jumping from antenna to antenna across a cellular network. So one of the big strengths of the Erlang virtual machine is the way it handles the atomic pieces of work that it does, and the way that the consequence that has on garbage collection. So as we know in Ruby, garbage collection is this thing that for most people, it's sort of an act of nature. It happens, and your app sort of seizes up, and it can be the problem that haunts you when you're debugging performance, or it can be the reason that you enter a weird locking state every time you have to do some thing that requires a whole lot of heap. The way Erlang handles things is when you make a request, or when you start a small Erlang process, and this is not an operating system process. This is a lightweight thing that you can have thousands or hundreds of thousands or indeed millions of these things. They each have their own chunk of heap. And when they're done, when they've done their thing, they just get cleaned up entirely. And so you can understand how that's not as complex a task as identifying objects that are still being referenced from somewhere. And it's something that can be done in a surgical way, where you just clean up this one thing that just finished. It does not impact the rest of the application, and you can see how leaking, just does not happen. So building on this foundation sounds great. Another aspect of the EVM that is powerful is this concept of fault tolerance. And fault tolerance simply means that a piece of your app can completely explode, and the rest of your app should be able to behave in a relatively normal way. And if you talk to people who write a lot of Node.js, this is a problem that they struggle with, right? Node.js can handle a lot of concurrency. It can't really do parallel very well, but it can handle a lot of async things, coming in and going out at the same time. But because you have one heap, just like in Ruby, you still have the potential for one rogue thing to ruin the party for everyone, right? To cause a memory leak that will just degrade performance until you have to intervene. And the way the Node community kind of addresses this problem is they advocate for something called microservices, which are these little sort of islands of functionality that can talk to each other, and they're sort of composed together to build an app. And the problem with this is, you have the challenge of all of these contracts between the microservices, and sharing code between them can be complex, and you find that you're building a whole bunch of different packages for different reasons. This is a moot point in the Erlang world, because these little lightweight Erlang processes come cheaply, they come in great quantity, and they clean up after themselves. So if we look at these requirements, right, if we look at how Erlang has ended up, and what a telecom company needs to be able to do, it's clear how they ended up here, right? You need calls to stay connected. If someone calls because it's emergency and there's a car accident, you need that call to be able to go through. You need to be able to rely on this thing always being up. And you need messages to reach their destination. You really need this thing to be up all the time, and you need it to be distributed. You need to be able to perform maintenance on equipment, take it out of commission, and the network should be able to kind of survive. And more we're seeing that our use cases building modern web applications, they're very similar, right? You've got APIs talking to other APIs. You've got progressive web apps that may have some data that they've accumulated while in an offline state, and now they have to kind of sync up their view with the rest of the world. You've got multiple clients talking to one server. So this is great, and we should all write a bunch of Erlang, except it is awful developer experience to write Erlang. Especially if you're coming from the Rails world, where we are spoiled with great tooling and a good set of opinions, or a set of opinions, many of which are good, that keep us kind of guided down a particular path and keep us productive and keep us efficient. This is on the opposite end of the spectrum, right? This is sort of where you need to be an expert to get any traction. So there's a lot of potential here, but we need it to take some other form before we can really extract some serious value out of it. So Jose is looking at this. He figures out that he wants to build up something that works with the EVM, with the Erlang virtual machine. And we want to make sure that it's compatible, right? That we can take advantage of all of the power that the telecom industry has built over the past few years or decades without having to write the kind of code that they write. And furthermore, when we start writing web apps with Erlang, we can see ridiculously fast response times. People will not believe you that you're seeing microsecond response times. For things that don't touch the database, this is commonplace to see this. And this is the reason why we can see WhatsApp at the point of acquisition when Facebook bought it. They were able to have a responsive chat platform that concurrently was serving for, I believe, 2 million chat sessions on a single AWS instance. So it's a $20 billion acquisition on a single AWS instance with this kind of speed. So there's great potential. We need to capitalize on it. He ends up writing Elixir, which is a modern programming language that compiles to bytecode that the EVM can read. And the cool thing about this is you can use it side by side with all of the Erlang stuff that exists in the world. So you can mix. You have one line of Erlang and one line of Elixir, and it'll all get handled properly. And this is what it looks like. And now you can see that if you squint, this almost looks like Ruby, right? And it's much more palatable. And we have modern language features like pattern matching, right? That help us write concise, easily testable code. So I hope you're starting to see that you're basically halfway there as a Rubyist. So Chris sees Jose's work, decides that it's time to take another stab at the RenderSync library, but he's going to write it for Elixir. And it ends up kind of growing into something bigger, and that is the Phoenix framework. So that's how we got here. Now let's look at the similarities between Phoenix and Rails in a little more detail. The way you start a Phoenix project is you use a tool called Mix. You can think of Mix as what you would get if Bundler and Rake had a baby. So this is equivalent to Rails new and then the name of your app, and you end up creating a bunch of files. And I apologize if this is hard to see, but it's going to actually install Brunch for static asset management. So you have the ability to use some node packages on the client if you're building completely in the Elixir world. And if we look at some of the folders that come out of this, we can see we have things like a default configuration with files that kind of lay on top of that default configuration on a per environment basis. We have a lib folder, which behaves just like the lib folder you're used to, right? You put code in there, but it is not watched for changes. You have to stop the server and restart it by default. And then we have a web folder that is like the Rails app folder, and it has familiar structure in there like views and controllers and models and a router, right? So there's very, very strong alignment here. Now, if we wanted to generate a resource, right, like the equivalent of using scaffolding, we would just run a command like this. And this is broken down into just the name of the model, the table that you wish to use in the database to store records, and then a schema. And this could not align more with the way it works in Rails. So you run that, and it's going to create a bunch of stuff for you, a controller, a model, some templates, and a database migration, and some working tests. So let's look at what we have now, that we have sort of more than just the default setup. We have something in there that's meaningful. So in the router, we have this section down here, if I can make this work. Oops. So if you look at like line 16, where it says scope, that should look familiar, right? We've got scopes, we've got namespaces. There's this thing called a pipeline, which I will loop back and come back to. But we're just defining routes in a way that's easily readable for a Rubyist, and delegating handling of those routes to controllers. In the controller, we have actions with the same names you're used to seeing. It looks slightly different. You can see that we've got some pattern matching going on in the create action here, which does a lot of work for you in that anything that doesn't match will be handled as like a 422 error where it's a bad request. And so you can kind of, some filtering is handled by the framework for you. So you don't have to, you can only handle the success case instead of having to do a lot of sanity checking inside actions. We've got migrations, which are so similar to Rails that I'm not even going to get into that because it's like almost a character for character match. And then we've got a basically complete set of tests for a CRUD use case, right, that include negative test cases. So you will, of course, have to customize this, but it's a great starting point. I cannot imagine it being more complete without going too far and, forcing you to rip out a bunch of stuff as you, flesh it out into a more real test. Templates, looks like ERB, right? And what you end up with is something that actually works. It ships with, I believe, a slimmed-down version of Twitter Bootstrap. I don't think it's the whole thing, but you can see that you've got CRUD already set up and working. They even go so far as to include the Elixir variant of better errors by default. So this is looking like exactly like a Rails app, but it's not quite. So if we go back to the router, we can see that we've got these things called pipelines and plugs. And one of the things that I remember hearing about in a RubyConf talk, which I think was Aaron Patterson, he's talking about how there's this huge stack of function calls. By the time you get to an action in Rails, you've got all of these middlewares that you go through. The path is much shorter in Elixir because They're basically just giving you a much simpler set of things to work with. And you don't need a middleware for all of the things in Elixir and in Phoenix that you would need a middleware for in Rails. So plugs are, in this case, essentially those little middlewares. They're functional programming modules that take a connection object in, which is just sort of a request and a response, and they emit a new connection object. And so some of them add headers, some of them check for the presence of particular headers and reject if they're not found, and so on and so on. What pipelines allow you to do is compose these plugs together and have a certain scope that is oriented towards responding to browsers, where you make sure you've got your CSRF token and you've got an HTML MIME type, and et cetera, and then you can have an API scope that is slimmed down, and it's just looking for the JSON MIME type, and maybe it's looking for a JSON web token in a header or something like that. So this really lets you mix things together in a easy to read and easy to maintain way. Even when things get complicated, it is an abstraction that scales up quite nicely. If we look at the controller, I want to draw your attention to this particular section here. So what you're seeing is an operator you're probably not familiar with, and it is called pipe forward. This is just shorthand for take a value and pass it as the first argument to the next function. So these two pieces of code here are equivalent, right? But you can imagine in a functional programming language, if you have 7 nested function calls, you don't want to be writing that as 7 nested function calls. It's much easier to read in a linear way and much easier to kind of reason about. Another thing that Rails developers will have to wrap their head around is this concept of immutability. And immutability just means once data is created, once a value is created, it cannot be changed. And what that means is you're not going to be creating, a hash map and then setting a bunch of values in that hash map. You're going to be doing something that looks more like this, right? Where you're creating a function that emits a new value given, the current value. And you can think of this as labels for values, in that you just have to reassign the label to the new result. The benefit here and the rationale behind this design decision is you can have 100% certainty that unless you have an assignment operator, you're not going to have weird side effects on some function that you're passing an argument to, right? There is no pass by reference. There is no pass by reference. There's only pass by value, and you can have complete confidence about what's going on. And it gives you fewer places to look when you're tracking down a problem. Perhaps the biggest difference is the way models are handled. So when I used to do Rails consulting and I was debugging performance problems, 100% of the time, active record was the first place I would look. Anyone seen one of these before? So active record abstracts away so much of the detail involved with talking to your database that you can run into performance traps even as an experienced engineer, just through the settings involved with eagerly loading related records or not. You can really get yourself into trouble. So when you're working with Ecto, which is the persistence library that Phoenix uses, you have to be a little bit more explicit about retrieving data. And so a query might look like this. And if you look at this piece here, this looks like a database query. And you can compose these together. So you can take a query and add more, selects to it, or take a query and update the where clause. And I mean, you're not really updating it, you're creating a new one given the initial query. And that's just sent to the repository, and it gives you the data back. This is the biggest sigh of relief I had when working with Phoenix for the first time, was dealing with data, because this is lightweight, and this is very deliberate when you're dealing with retrieval of records. And you can be sure it is doing exactly what you want it to do and not doing you any favors that are hurting you behind the scenes. So I'd like to wrap up here in talking about how you might use some of this stuff that we've talked about today. How, if you have a project that you're halfway into, or you have a mature product maybe, And some of this sounds like it might just be the right solution for a problem you're facing. What can you do about that? So first, we have to realize that one-shot rewrites are expensive, and even if you can afford them, they're just flat out dangerous. It's really never a good idea. You should avoid it if at all possible, to just write everything again and then switch over. And the reason is, while you think that you're going to be able to cross all your T's and dot all of your I's and make the switch seamlessly, what ends up happening is you forgot something, and things start to fall apart, and your users pay for it. So the approach that I am going to advise that you guys take, and there are other approaches that may provide a deeper level of integration, but this is something that I've done before that's easy to maintain. It's using this concept of a reverse proxy. And just like the way a proxy will make all outgoing requests from you appear like they're coming from one server, a reverse proxy is something you put in front of something else. And so incoming requests from the reverse proxy are sort of delegated to another server. And in this case, you can have Rails acting as the reverse proxy, and you can, there are a couple gems out there, and I'd be happy if you find me afterwards. I can point them out to you. But you can say this resource is handled by the service at this URL. And that can be inside a private cloud, or it can be another public server. But you basically don't change your API surface that's facing the outside world at all. You're just starting to delegate, actions one by one, delegating resources one by one, until potentially, if this makes sense, you can switch and have Phoenix be the reverse proxy that's delegating all of the remaining endpoints that haven't been migrated over yet to your Rails app. And then if it makes sense, you can actually remove the Rails app entirely once you've completed everything. But this is a way that you can deal with the fact that your products are a moving target, right? You can't stop feature development, go into a hole for 6 weeks, and build everything over again. So in closing, Elixir and Phoenix are fast, and together they have strengths in areas where Rails has inherent problems that we're not going to find our way out of, just because we need to hammer a nail and it's a screwdriver. The productivity benefits that Elixir brings to the Erlang ecosystem, they rival that of Rails. And if there's a particular thing that doesn't exist yet, it's remarkably easy to take a couple small libraries and mix them together. The ability to kind of do it yourself is so much easier in the Elixir world compared to the Rails world, simply because you have a lot of very useful primitives to work with. And finally, you guys hopefully can see from this that there's a lot of similarity between these two ecosystems, and you have a big head start if you decide that you want to start exploring further. Finally, part of the reason I'm here, I'm hiring for my team, and we're a purely remote company. If you know Ember.js or if you know Phoenix, I will teach you the other one, and it's an awesome product, and you should come and find me if it sounds interesting to work with some of the stuff I've talked to you about today. So thanks very much, and I'm not sure if I have time for questions, but come find me, and I'm happy to chat up about this stuff. Thank you.
So we can take 2 questions. So if anybody has any questions for Mike, we have 2 minutes.
Hey, so you talk about a few good points of Phoenix and Elixir. What are the drawbacks? Everything has good points and bad points about it. So what is the drawbacks that you saw when you're doing a Phoenix app?
So I think the biggest drawback is the size of the developer community, and I'm putting my CTO hat on. The number of Ruby developers that you could hire from is large. The number of Phoenix developers, just because it's a younger project, is very small by comparison. I think that there is a little bit of a conceptual hurdle that you have to get over to work with any functional programming language. If you've been writing Java for 15 years and you're sort of locked into that mindset, it's a little bit hard to make that leap. But a lot of the drawbacks I expected to see turned out to not be there. Like I expected that I would miss having an authentication solution that I could just drop in. But it turns out, there's a library with some great primitives, and in 25 minutes you can assemble them the way you want. I expected that it would be a little bit too early to put this kind of thing in production, and I found that that's not the case. So I'm still looking. I mean, I'm a skeptical fan, but it's turned out to be across the board very good for general purpose stuff.
Hi, Mike. Thanks for the introduction for the Phoenix framework. So, like on top of that, as far as the Rails application is concerned, we can say that it is a singleton application. But with the Phoenix framework, we can say that multiple applications can be handled side by side. So I would like to know how it will be impact when any application is having the multi-threading concept. So what would be the impact if we're using the Phoenix framework?
Sorry, there's a little echo. I think you're asking about side-by-side applications and availability?
I'm asking about the multi-threading application, how Phoenix framework will be impact when any application is having the multi-threading or parallelism concepts.
So multi-threading is not a concern with Elixir because it uses actor model for concurrency, so you don't have the typical challenges around deadlocks. You kind of pass it immutable data and use something called a gen server, which is like an Erlang primitive that makes it easy to do inter-process communication. So when I say that it's easy to build a distributed system with this, I mean that the building blocks and the abstractions are in place that make it so the code you end up writing the easy way happens to also work in a multi-threaded situation in a distributed system. Does that answer your question?
Yes, thanks.
Sure.
So you can catch Mike later and ask him all the questions about Elixir and Phoenix. Thanks, Mike.
Thank you.
That was an awesome talk.